In this video, we'll be talking just about how to rationalize a denominator. So, this is again best done through example. The basic understanding of what rationalizing a denominator is we're trying to make the bottom a rational number in each of these fractions. So the square root of 2 and the cube root of 25 do not give us integers or any sort of fraction as their answer, namely because they can't be simplified. And so because of that, they are actually irrational numbers. So the idea here is we're going to try to make the bottom, we're going to try to make them rational numbers. The way we do this is by multiplying top and bottom by something which will allow us to cancel out and get rid of the square roots. In this case, so in this example, it's the square root of 2. By doing that, what we end up with is we end up with 5 over 3 times the square root of 2 squared now times 5 square root of 2. The square root of 2 and squared will cancel, and so we end up with 5 square root of 2 over 2 times 3, which is 6. Okay? So effectively, we were able to move, by doing this, we were able to move the square root of 2 up to the top, leaving a 6 in the bottom. In a similar way, in this one, now here we multiplied by the square root of 2 because we wanted to square it to cancel out the square root. Here, because we have a cube root, we actually need to multiply by the cube root of 25 squared. Of course, if we do it in the bottom, we have to do it in the top as well, because essentially all we're doing here is multiplying by 1, which we know doesn't change anything. In the top, that gives us the cube root of 25 squared over the cube root of 25 cubed. Now the top, we can bring the square to the inside. We can swap the order of the root and the exponent. We know that it doesn't matter what order we do it in. In other words, we could go ahead and square 25 and we would end up with 625. Of course, if you notice something here, what we actually have is the square root of 25, the cube root of 25, times the cube root of 25. Well, that's 5 times 5. And then we'd end up with another one. So 25 and 25. On the bottom, we know they cancel and just give us 25. Well, we can now, since we have 3 of these, we can pull them to the front. So we end up with 5, the cube root of 5 over 25. Well, then the 5 and the 25 cancel. So we actually end up with, this cancels one of the 5's in the bottom, and so we end up with cube root of 5 over 5. And that is our answer. And now it is once again time for you to work out an example. So go ahead and rationalize the denominator of both of these expressions. So again, I'll give you, I'll count to 3 and then I'll reveal the answer. 1, 2, 3. So you can now go ahead and check your solution. For more complicated denominators, we have to multiply by something called the conjugate. So what do I mean by a conjugate? Well, a conjugate, anytime you have 2 terms and you have a sign with addition or subtraction in between the 2, the conjugate just changes the sign. Like so, okay? So here, the minus turns to a plus, the plus turns to a minus. But the simple thing we can use to rationalize denominators. So, for example, if I want to rationalize this denominator, I just multiply top and bottom by the conjugate. Of the denominator. So how does this help you? Well, the reason this helps you is because now, so the top, we have 2 times 3 minus square root of 7 over 3 plus root 7 times 3 minus root 7, which doesn't seem very helpful. However, if we use the distributive property here, we end up with, we can distribute this whole expression to the 3 and to the negative root 7. Similarly, in the top, if we distribute in the top, we end up with 2 times 3 minus 2 times square root of 7. We haven't done a lot with the distributive property, so it's worth going through now. I distribute this, so I end up with 3 plus square root of 7 times 3 minus 3 plus square root of 7 times square root of 7. So simplifying the top, we get 6 minus 2 root 7, which doesn't seem all that great. In the bottom, we can distribute again. We end up with 9 plus 3 root 7 minus, make sure the minus gets distributed as well. We end up with 3 root 7 minus square root of 7 squared. Now, two things. Because I'm adding a 3 root 7 here and subtracting a 3 root 7, those will actually cancel. The square root of 7, meanwhile, becomes just 7. So I end up with 9 plus 7. And I have a 6. I still have the 6 minus 2 root 7 on top. But that gives me 16 in the denominator and 6 minus 2 root 7 in the top, which I actually can write as, I can factor out a 2 out of the top, so I end up with 2 times 3 minus square root of 7. I can factor out a 2 out of the bottom, and now the 2's will cancel because it's a multiplication in a division. 3 minus square root of 7 over 8. So that is my final answer. As an additional side note, this process that we did through here of using the distributive property twice, you probably remember this better as foiling, F-O-I-L. We'll talk a bit more about that in a coming section, but for now, just think of it as the distributive property. And now it's time for you to try an example, so go ahead and rationalize the denominator for that expression. So, on the count of 3, I'll reveal the answer. 1, 2, 3. So now you can go through and check your answer. A bit of a convoluted process for right now, but we will eventually learn about foiling, which will help these steps go a lot quicker. If you would like more practice at learning how to rationalize the denominator, be sure to look at pages A23 and A24 of the textbook, numbers 6, 7, and 51 through 54. In our next video, we'll finish off this section with rational exponents and their properties.